So this talk is on extending Kubernetes. So can I get a show of hands of people who have used Kubernetes in any capacity? All right. Less than half of you guys. Excellent. So I'll go over Kubernetes and kind of the basics of what it is, and then we'll talk about why you might want to extend it, and then also we'll do a demo of extending it. So who am I? My name is Jason Gerard. If you've been coming to Code on the Beach, you've seen me here before. I've lived in Jacksonville all my life. I've been working in the tech industry since 1998. I've done healthcare, insurance, finance, telecoms, worked for some of the big cloud providers. Working with Ken Bedwell, co-founded Navuli. We are sponsoring. Stop by our booth. That'll be the only plug I give, don't worry. And then you can find code for this and some other code I've done on GitHub. Some random Kubernetes-related blog posts I've made, and then I am on Twitter also. But I only do tech stuff or complain about Publix selling me expired food on there, so which has happened like 5 times. And then my email. All right, we'll get started. So if you've heard about Kubernetes and you're not really familiar with it, it is quickly becoming the de facto way to deploy things in the cloud. If you're working with a containerized workload, it is the target to choose. I don't hear anything about Mesos or any of those other original orchestrators that were out a few years ago. Kubernetes won that war. Hands down. A few people still cling to using Docker Swarm, Sean, but for the most part, Kubernetes is how you do this now, and I kind of like it. It is the new operating system. So, you're going to be cloud native. Kubernetes is essentially the operating system you're going to run on. So what is Kubernetes? All right. So it's a distributed scheduler. So it allows you to schedule your workloads to run across one or more machines. It has service discovery, so it allows your workloads to be discoverable by each other and outside. So you can share it with the world. It allows you to centralize your configuration for your application. It allows you to quickly scale out. So if you need to, it's Black Friday sale, you're a retailer, you need to scale up your availability. It makes that super easy to do. If you're going to deploy code, right? So I've worked at companies where deploying the next version took 2 days. Starts on Friday night, ends sometime Sunday morning. And you may or may not be in the office that entire time. This allows, there's still work that you have to do, but it allows you to deploy your code quickly, and if you find issues, to roll back to that previous version quickly. It has desired state configuration, so you specify what you want your environment to look like, and it guarantees it looks that way. So there's no you having to worry about writing scripts to deploy stuff to the right nodes and the right number of things. You just say, I want 5 copies of this running, right? And it makes sure that those 5 copies are running. And then it is self-healing. So one of those copies dies for whatever reason, it will restart it. One of your nodes goes down, it will shift the workload. So you're able to stay up and running. All right. So this is kind of a little diagram of how a cluster works. So in a Kubernetes cluster, you have compute nodes. That's what's going to run your workload. So your code is going to run on those nodes. And then there's another server that's the master server. That's where it kind of schedules everything. It's got its API running there and its controller and scheduler. Each one of your nodes has a service called a kubelet that runs. That kind of keeps everything going, and it also manages the proxy so you can have your network running and those things talk over there. So I mentioned it's a distributed scheduler, and that's something I want to point out here. So when you think of your computer today, running processes, so you've got, you write some code, it runs in a process. You may have one or more threads running. You will have at least one thread running, but you may have more threads running. The OS is in charge of scheduling that. So when this thread needs to wake up and do work, the OS handles all that. And then your OS is sitting on top of all your CPU cores, and your operating system is providing access to your memory, your disk, your network. So Kubernetes does the same thing, but in a distributed cloud scale. So in Kubernetes, you don't have a process, you have a pod. And that pod can have one or more containers running inside of it. Kubernetes handles the scheduling. Instead of cores, you're running on Kubernetes nodes, and then it handles all the shared resources for randomness. Now, obviously, it's using all the operating system functionality under the hood, but at a higher level, it is essentially your operating system. So that's super high level overview of Kubernetes. Hopefully that was good enough. Now we're going to talk about custom resources. So Kubernetes actually has several primitives that are there that you can build on top of. So we talked about a pod. There's a deployment. So a deployment says, I have this piece of software. I want it to run. I want it to have 5 copies of it running, and I want it to run this image. And you tell Kubernetes that, and it makes sure there's 5 copies running, and it runs that image. You have a service that says, I want this that software to be exposed. I want other things to be able to talk to it. Right? So either I'm exposing it inside my cluster, other things in my cluster can talk to it, or I'm saying I want to expose this through a load balancer to the internet. Maybe it's a website that you want to expose. So all those are defined through YAML or JSON files. You all do everything declaratively. So custom resources in Kubernetes allows you to create your own resources so you can define your own things in the same declarative way. And it allows you to use the kubectl command to manage those. Just like you manage any other Kubernetes resource, you can manage your own resources through the same command line interface and the same APIs. So some examples of this, if you've ever used the ingress controller in Kubernetes, it works a very similar way. You have an ingress resource definition that says, I want to expose these services on these paths, and I want to tie this TLS certs to it. And what that does behind the scenes is it spins up an Nginx. Well, it depends on the one you use. The default one is Nginx. It'll spin up Nginx and make sure that all that routing happens. If anyone ever used Jenkins X, awesome. Nobody, which is about what I've seen in the real world too. So is everyone familiar with Jenkins? All right. So you got Jenkins, it's a big Java blob, builds your code, deploys it. So Jenkins X is a redo of Jenkins that is Kubernetes native. It has a whole set of infrastructure to run your app, deploy it, give you test environments, all those things, and it's all built on Kubernetes. All of the resources inside Jenkins X are custom resources that they've built and they monitor there. Anybody running a database in Kubernetes? One guy. All right. What are you running? MySQL. Okay. Did you just do it yourself, or did you use one of the operators out there? One of the operators. Okay. So the operators are essentially they're a custom resource with a controller tied to it. So it allows you to, when you set it up, you're saying, I want a MySQL, I want it to replicate, I want all those kinds of things. Instead of him having to do all that stuff himself, he can just install one of these operators and says, I want a MySQL, and I want it to be this size, I want to have this disk. And it knows how to provision those resources inside Kubernetes that are optimal for MySQL. And so that's kind of where you see a lot of usage for custom resources right now are it's this operator pattern. So the idea is to encapsulate the knowledge needed to run that database inside a custom Kubernetes controller extension, and then you declaratively use the Kubernetes API to say, I want a database that looks like X, Y, or Z. It knows how to run that for you, so you don't have to do any of that operational logic that your DBA would be doing to run that database for you. Any questions so far? Excellent. All right, so why would you extend Kubernetes, right? If you are going to use declarative configuration, if you're not using declarative configuration for what you're trying to do, then this is not a good fit. If you want to compose a bunch of Kubernetes primitives together, which is what we'll do in the demo, to run your application. I'm going to give you an example. I think it'll tie all these things together better in a minute. And if you want to encapsulate that operational logic, you would use this. So your extension options, there's a SDK out there called the Operator SDK that you can use to kind of bootstrap and get some of this started. It is still being developed. It's not a 1.0 release. I was actually going to do some stuff with that for this presentation, but some of the things that I needed were, I had to compile from source. They weren't in an actual release, and I decided not to deal with it. There's also Kube Builder, similar philosophy. Both of those use code generation. They both target Go. So if you're using these tools, you're building your stuff in Go. Any Go programmers in the room? 2 people? Awesome. And then roll your own, which is what I've done for this example. So I'll show you the code that's needed for this. It's not a whole lot. And so these SDKs, they give you like a nice standard way of doing things, but they do have a lot of boilerplate that sits on top. So I recommend if you do want to play around with this, roll your own first so you can understand what's going on under the hood before you jump into one of the SDKs. All right, so this is the scenario that I have, okay, that we're going to use. I have an application that I want to manage with the kubectl command because all my stuff's deployed in Kubernetes. All right, I have a rule in my company that says anything that gets deployed as an application needs to be deployed through a deployment object in Kubernetes, and it needs to have a service created automatically that corresponds to it. I don't want anyone doing anything outside of those boundaries. And then also, because I want to move fast and break things, whenever the Docker image gets updated in my registry, I want it to automatically deploy that latest version to Kubernetes for me. So my deployment consists of Docker push. That's going to go up to my registry, which is going to be running in Google Cloud for this example. And when that happens, I want it to automatically roll out and do a deployment into Kubernetes. So that's what we're going to do. So time for some code. All right. So can everybody see that okay? All right. So this is the kubectl command. It's got a ton of options here. But one of the things I want to show is that my cluster is running and that there are no pods running except for my little debug pod, which is a Ubuntu container that I will use to show some things off. So I'm going to show you my application. I'm just going to do it over here. It'll be easier. Zoom in. All right. All right. You don't need to see that. Yeah, it's just main.go. Thank you, Micah. All right, so this is the application. This is my awesome application. It's going to make us millions of dollars. We're going to IPO. It's going to be great. All right, so all it is it's a web server that spins up, says what port it's listening on to the console, and then whenever you make a request to root, it responds with version 1.0. It's brilliant. It's version numbers as a service, okay? So It's going to make millions. All right. So that's my application. And we can see that. Let's see. I'll build it. I'll run it. There we go, we're listening. And then just to prove that it works to you, we will, I can't type. Wow. Wow, this is bad. All right, there we go, version 1.0. That little percent sign there, that's the Z shell telling you that that's where the line ended. So you can ignore that. So there we go, there's our service. All right, I'm ready to pitch to investors, get this going. I just need to get it running in Kubernetes. So what I could do is I could create a YAML file to define the deployment, to set up all the parameters I need, and then deploy it, create a service and all that. But my organization has decided that they want everything to be the same way. So we've created a custom resource that we've called an app manager, because naming things is hard. So let's see. I remember. Yeah. All right. So this here is my custom resource. So this is how you define everything in Kubernetes is defined declaratively. So you can do it in JSON, but YAML's better. Right. So I say this is a custom resource. I give it some metadata. So this is appmanagers.codeonthebeach.com. That's my group. That's actually my full name. My group is codeonthebeach.com. So this is how I namespace things essentially when it comes to here. So we'll see that getting used in a little bit. And so I can define plural and singular. So app managers and app manager, that's how I'll actually refer to this on the command line. When I can say kubectl get app managers, and it'll show me all the ones that are there. This here, the open API here, this is how you define what it actually looks like. So what I'm saying here is I've got an API version, I've got a kind, these are copy pasta obviously, and then here's my stuff at the bottom. And what I'm saying here is that my app manager has 3 properties. It's got an app name, that's a string, it's got the number of replicas, which is an integer, and it's got an image, that's a string. So only things I can set for this is what do I want to call it, how many copies of it do I want to run, and what's the image to run. Okay, that's it. And this code that I've written will take that information and it'll build a deployment and a service to map all that out for me. So let us go ahead and add this guy to our cluster. Actually, let me show you API resources. All right, so this command here shows me all of the different resources that this Kubernetes instance has available. And so my Code on the Beach app manager is not part of this list. So I'm going to apply it. Let's see, deploy, CRDs. All right, so now that resource is created. I'm going to do this again. And there we go. App managers, Code on the Beach. Excellent. So now I can say kubectl. If you see me doing this K shorthand, I have a Z shell plugin that gives you all these shorthands. That's why. If you don't have that, you would type the full command. Oh, yeah.
That's a risky proposition. Yeah. You minimize the window screen so that it's more in the middle of the.
Let me do this.
Yeah, just like, yeah. There, look at that.
Okay. There. How about that? All right. Tell you what. Let's do this too. There we go. Get it at the top.
Sorry, can you explain the dash table before?
The K command. So I'm using a plugin for Z Shell, which is the shell I'm running here, and it just has a bunch of shorthand shortcuts for Kubernetes, so I don't have to type kubectl every time. I can just type K. So I can type, hey C, get context, right? Instead of, otherwise I'm typing config get context. Like I'm typing all this stuff out, right? So I may go in and out of the shorthand. So if something doesn't make sense, feel free to ask. I just got so used to using it. Anyway, so let's see, get app managers. All right, so I deployed the CRD, but I don't have any app managers. So since I've defined what this resource is, let's look at an actual resource. So let's see, cat. No. All right. So this is my definition. This is my resource. So I've got an app manager. I'm naming it example app manager. My app name is awesome app. I want one copy of it to run, and I'm going to deploy this image here, gcr.io/COTB 2019 example. And so what's going to happen is I'm going to apply this to Kubernetes. And all right, so now I can say kubectl get app managers. And then there's that app manager. And then I can do things like, describe it. I can do everything. I can delete it. I can do everything that I would do with a normal Kubernetes resource, with this. So cool, I did that, I deployed it. So let's see if it's running, right? It's not running. Well, all I've done so far is told Kubernetes that I've got a custom resource and it looks like this YAML structure, and that I've deployed one of those custom resources. I don't have any code running in my cluster that will do anything with it. So Kubernetes is just like, okay, there's this thing here. I can tell you all about it, but you don't have any code that's doing anything with it. So I need to deploy some code now that will actually monitor for these and do stuff with it. So I've written a controller that'll do that, and we'll look at the code in a little bit. But I'm going to go ahead and deploy the controller. So, yeah, thank you. So let me show you the deployment for that first. That's a traditional deployment. Yeah. So this is a traditional Kubernetes deployment YAML file. All right. So this is some of the stuff. So you see my app manager had like 3 lines on it, and this has got a bunch of stuff in it. So what I'm doing here, it's an app manager. I want one copy. Here's my template for my container. I'm going to run this image here. I've set some environment variables here, some liveness and readiness probes, and I've got some GCP credentials that I'm injecting in through a secret. And I have to have all that stuff so this guy can work, right? So my little app manager that I've done abstracts all this stuff away from me, so I don't have to worry about any of this. So as the application developer, what I have to do is much easier than someone who's running these things for me. So I'm going to go ahead and, first of all, make sure my secret is still in here. Yes. All right. And then I'm going to apply this guy. Nope. Feel free to correct my spelling as I go, too. All right. So I'm going to get pods. And I'm going to show you the logs for the app manager controller. All right. So, hey, cool. This worked already. So my app controller started up. Kubernetes told it, hey, I've got an app manager. That's what that add is there. And it says, okay, let me go pull that image. Let me create a deployment, create a service. You can see up there that now I have the app manager controller running. And then I have awesome app. At the time, it was in container creating. it should be there. So it automatically, when it came online, it looked at the metadata that I already deployed and it said, oh, I got work to do already. So it went ahead and kicked it off. So let's, I'm going to leave that open. And then we're going to not do that. Let's see. We'll say get deployments. We can see I have an awesome app deployment. And I will get services, because that was one of my other requirements. I have an awesome app service. And I'm on, I'm using Minikube here, so do this. Bam. Hey, look. Version 1.0. We're live. Ready for the money to start rolling in. All right, so how did all that happen behind the scenes? Let's look at some code now. Let's see. All right. So we've got like 2 Go guys here. So if you have any questions on what's going on in the Go code, let me know. This is the important bit right here. Some of the important bits. So first thing we do is we say, I'm using the Go client library. It's called Client Go. It is essentially going to be the most up-to-date Go client for Kubernetes, because it's what's used by Kubernetes internally, because Kubernetes is all written in Go. But there are other language bindings too. Essentially I say, hey, if somebody's passing this command line, use it, tell me where my Kubernetes config is. Otherwise, I'm running inside a cluster. So whenever you run a pod in a cluster, Kubernetes all the pods have the config injected into them, and this library here knows how to read it. And so it does that. Basic setup, I say so let me take a step back. So what I've done actually is I'm using GCR as my container registry. So Google Container Registry. And what I did is I set up a binding. So anytime I publish an image gets updated in GCR, I will get a pub/sub notification. Okay, so Google pub/sub will send me a little message that says this image has been updated, and so my code is going to be listening on that using the whatever project ID I have and a topic I've called GCR. It's going to be listening there, and it's going to notify it, hey, this image has been updated. And then I have some more code that uses that app manager definition that we just looked at that says, okay, is this an image I care about? And if so, let me take action on it. So that's just kind of my setup code here. I'll show you this code. Essentially, this is the Google specific GCR stuff. So essentially, it takes the JSON. We get a message that looks like this. It has an action, has a digest, and it has a tag. The tag would be the GCRIO COTB 2019/example latest, the image name. The digest would be that with the SHA digest of the latest version, and action is what happened. It was inserted, it was deleted. Well, we don't care about those. We just pretty much care something happened, redeploy it. So that's not the Kubernetes specific bits. Let's go to, oops. Let's look at my controller. This is the Kubernetes specific bits. Any questions so far? All right, it's either good or bad. All right, so I've got my controller here. All right. What I'm doing is I'm saying I want to watch for a resource. I want to watch for app managers. All right, and I'm going to use the namespace I'm running in. You can define namespaces on here. I just ran everything in default for ease. So tell me when anything changes with an app manager. All right, that's what that list watch is. And then you define a handler and you say, when something is added, I want you to call this func here. When something's updated, call this func. Deleted, call this func. All right. Then I tie them together here with this controller. And then I run it. And I say, hey, just run forever. So what happens when the add happens? So I create that resource, that app manager. I apply it. This function gets called. I have my type here, app manager. So I have to do a type assertion. Let me show you what it looks like. But it's essentially the Go version. This is the Go version of that YAML that we did. You have to do JSON tags on here because internally it's doing everything JSON. But this is the representation of that YAML. So I've got replicas, I've got an image, I've got an app name. And then that's my spec. Then I've got a global type here. It's got some Kubernetes specific metadata. And then this is my type representing my list. Go doesn't have generic, so you do this every time. So let's see, let's go back to controller. All right, so when add happens, what I'm gonna do is I've got my watch. I'm gonna die over here. I'm gonna register a handler on my watcher and says whenever you see this image, run this function. And then I'm also gonna go ahead and since this is the first time it came through, I'm gonna go ahead and run it there too. For update, it's very similar. But for update, update runs periodically. So that list watcher, you can set an interval. And anytime, since I said to watch for everything, it's always going to send that update event. Even if nothing changed, it's going to say, hey, here's the current state. 30 seconds later, hey, here's the current state. I don't want it to redeploy this app every 30 seconds if nothing's changed in it. So essentially that's what I'm doing there. I'm like, hey, there's no changes. This deep equal here, I get an old and a new. Nothing changed, just ignore it. This is a special case I'll show you in a minute. And then the rest of this is pretty much the same as the update. And then the delete, all I do is remove my handler for that image. So if that image comes in again, just ignore it. Yes?
You're saying for the update, is it caching or how does it know something's been changed?
Yeah, so Kubernetes is, so if we look up here, I'm setting this up. So the client has a cache that it uses, and so you define what you want your watch to look like up there, and then you give it to the cache, this informer that it has. And so it will, see right here, this is the update interval, right? So if anything happens, I'll get a notification immediately, but it'll also notify me every minute that what the current state is. So if I get out of whack for some reason, I don't have to wait for an event to happen. I can verify my state every single time and then make sure everything's correct. So instead of just waiting for something to get added or updated, it'll also notify me every minute, here's what your current state is, and it's an opportunity for you to verify, is my current state what I think it should be, right? In my case, if my current state is, if what it tells me my current state is the same as what it was before, I'm gonna ignore it. I'm not actually gonna go out and verify my state. But in the case of something more complex, you might wanna verify, is my current state the same as what I think it is? Does that make sense?
It works for multiple for all the nodes?
Yeah, so this is what this is doing is it's watching for that app manager's resource that we defined. So it's going to tell me anytime that gets added, changed, deleted, and it's also going to tell me every minute, hey, this is what it looks like right now. This is what it used to look like. And so in my case, what it used to look like and what it is right now are the same, and I'm not going to go inspect the internals that I'm doing. I'm just going to say, I'm good. and go on.
So it's looking at the hash to see if the hash changed.
I'm not sure internally how it's doing it. What I'm doing, yeah, I'm doing a deep reflect right here, deep equals.
Yeah.
So that's essentially taking the old object and the new object, and it's going to go over everything and see if they're different at all. Do an equals on each one of them. So here is the meat and potatoes of it. So this reconcile function that I've got here. So I take in that image update message that I'm getting from GCR, if I have one, and I'm taking in the app manager. That's what the state should be, the app manager, and the update message is any message I've received from GCR. So I'm going to create a couple clients for the API, a deployment client and a service client. I'm going to check to see if they exist. If they do, I'm going to update them. If they don't, I'm going to create them. That's, I won't go into too much detail. I've got a little bit of tracking for internally, so I'm tracking the revision number, and I'm essentially adding that as metadata onto the object. And then here's where I create those objects. So we'll look at the deployment since we looked at one earlier. So this is how you would create a deployment in code versus in YAML. So you can see it's still very declarative, but what I'm doing is I'm adding some labels to it. I'm making it look the same way. I'm pulling the replicas off of that app manager guy we created. I'm pulling the image off the app manager, and I'm giving it a name. I'm naming the container after the object and doing this. I'm giving it a version of -1 since here I'm kind of doing a hack to force redeployment. So when I get an update to a new version needs to be deployed, I change the container name. And what happens there is Kubernetes will do a rolling deployment of out there. So it will spin up a new replication controller, and then if I have 5 copies, let's say, it'll add a copy of the new one and then decrement a copy of the old one, and it'll keep doing that until I have 5 new copies and 0 old copies. And if I need to roll back because that version was bad, I can tell it to roll back, and then it'll do the exact opposite. It'll be 1, 4, 2, 3, until we're back all 5 in the new version, 0 in the old version. So, any questions on that? Dope. All right. So let me show you a few other things we can do with this. All right, so you can see here I keep getting an update. All right, that's that 1 minute interval that we talked about. So now what I'm going to show you is, so I've got version 1.0 published, and it's been wildly successful, version number as a service, and so I need to deploy version 2.0. And so I'm going to do that by updating my code. I can remember where it was. All right. So now we want to deploy version 2.0. So I'm going to edit that. One thing. So I'm in my debug node running in the cluster here, and I just want to do a looping curl to show you guys the version number change as we go. Let's see. Let me cheat really quick.
I'm not sure you got curl on that last one.
It would appear I did not.
Maybe you knew some magic I didn't know, so I was going to
No. I'm just blindly typing here, Sean. Please tell me.
My bad.
All right. So this is just curling my my service every 1 second, putting a timestamp. showing you, hey, it's version 1.0 still. So now we need to deploy this guy, and because I've defined all these things, my deployment consists of pushing to GCR. So we will, I'm going to show you my task file here. I'm using task. It's like make, but better because it's YAML, right? YAML's always better. So we're going to build our example code, right? We're going to run go build. Actually, it's going to run this Linux version because I'm running this in Docker, so it's going to be Linux. And then I'm going to package this up in Docker. I'm going to do a Docker build, and then I'm going to do a Docker push, and that's it. So if I run that, Docker example, it's going to build that guy. It's going to push. Ah. 1 minute. I'm not authenticated into the Google command line at the moment with the right account.
Where GCP command line times out for you?
I'm authenticated into the wrong account.
Happens to me constantly. Were there shared keys between two companies? Nobody else? Yeah, it's super annoying. Like it'll work for like 5 minutes, and as soon as you blink for a second, you try to run it. Yeah, you gotta keep logging back in. It's really annoying. Thought maybe you ran out of funding.
So I'm actually using the 300 free credits right now for this. And because I'm just using GCR, I still have 300 free credits. I'm not using any compute power, so the GCR is not billed. Okay, so let's run that again. Let's rebuild it again. All right, so we should see that. Look, 2.0. And so if we go back and we look here, we'll see that I got that. I called update existing deployment. So what happened is GCR saw that the image changed. It pushed a message over PubSub. My code running inside Kubernetes watched that. Since we had registered that handler func that said, whenever I see anything for this image, run reconcile. It saw that. It ran reconcile. There you go. So if we look at, we still have that one running, but we now have a new pod that's only 39 seconds old. So now we can also say that's cool. I published the image, and I did that through Google. Now let's go ahead and update our app manager itself, our resource. So I'm going to. I could edit the file locally and then reapply it, but since this is running inside Kubernetes, I can also do a kubectl edit on it. I can say edit, I want to add it app managers and example app manager. So there we go. So Kubernetes added a bunch of metadata onto it. But here's my bits here, spec. So I want this guy to have 5 copies now. So I'll change replicas to 5. That got applied. We're seeing we're updating existing deployment again. We go back over here, we're still version 2.0. But now you can see we have more stuff running. So now we have 5 copies running. So what I've done in this example is use an operator so I can enforce the way my company's application developers get things into Kubernetes quickly. I have mandated that everything is done through this app manager, and when my app gets deployed, I want it done as a deployment, and I want to have a service tied to it. Here's the cool thing too. So right now, I've got a couple of Kubernetes resources. I've got the pods, which are my app. Those are being controlled by a replica set, which is tied to that deployment we created. But we also have that service. All right. So those are independent pieces of software. And so in a normal situation, I would have all these different pieces, and they could get out of sync. I could, somebody deleted my service, but my deployment's still there. I'm like, why can't I connect to this? It's right there. They're independent of each other. What I've done here is I've tied them all back to that app manager. So if I say I don't want this app deployed anymore, instead of going in and cleaning up the service and cleaning up those, if I just delete the app manager, because I've set it as the owning object for these, if we delete this app manager, you'll see that my curl is about to time out, and my pods are shutting down, and my services, the service is no longer there. Okay, so I've tied all that to that app manager, and I did that in code when I set an owner reference, and that just builds this little thing. It's owned by an app manager. This is the API version, the name, the UID. There's a little bug in the client where your object, these values are null. Spent a lot of time hunting that down until I found the GitHub issue. So I had to hard code those. But what I'm saying is this resource is owned by this other resource. And what you can do is you can, there's a couple of propagation policies in Kubernetes, so you can say how those child resources can be handled and deleted. You can also say, if I delete this app manager, delete everything that I own. And Kubernetes just does that for me. I don't have to write any of that code to delete it and make sure that stuff got cleaned up. It just does the cleanup for me. You can tell it not to delete the child. You can say cascade equals false on your delete command, and it will delete the parent and it won't delete the children. That's actually what where is it in my update? That's actually what this code is doing. What it does is it adds a finalizer, and so I have to make sure if it's the finalizers that are different to let it go through. Otherwise, it was not deleting and redeploying and stuff. So, any questions? Anybody? Yes.
So what we do is equal to the OpenShift, or is different than OpenShift?
So OpenShift is a layer that runs on top of Kubernetes, and a lot of stuff in OpenShift is going to be implemented doing the same kind of stuff, right? So
OpenShift already providing that what you
exactly. So OpenShift, you can go into OpenShift and say, I need a database, right? MySQL, whatever is in the OpenShift marketplace or whatever it's called. A lot of those are backed by essentially this kind of code, right? That's just how they're implementing those things. And so
they have their own app managers and
right. So I just, I was like, let me think of an example. I came up with this concept. So you could use the same kind of, even with OpenShift, you could use the same scenario here. If you wanted your application to be managed through a resource, a custom resource you own, so you could define declaratively, this is what I need it to do, right? Instead of having to generate a bunch of deployment files and services, maybe you've got templates and you're running like customize on it to inject all that stuff into it, and they're still kind of disparate systems. You can use this to say, no, this is how all my applications, there's always an exception, but this is how all web apps get deployed inside my organization. They have to look like this. They have to have these resources available. So I could also use it to provision storage or any of those things because I'm talking to Kubernetes directly at that point. So I can declare what I want, and then all the logic behind that is encapsulated. So I don't need you as a developer to know that this thing needs 100 gigs of storage, right? I just always want every app to get 100 gigs of storage, let's say. So I can encapsulate that in my logic here. And then you as an app developer also, if I need to change that, you don't need to worry about it. You don't have to redeploy your app. You don't have to update your config because now we're going to 150 gigs of storage, right? I, as the operator, I just update my code and redeploy my code, and it takes care of it. Any other questions? So this is not something you just want to jump into like, hey, I've never used Kubernetes before, I'm going to start writing operators. I don't recommend that. If you've never used Kubernetes before, definitely try it out. If you want to try it on your laptop, Minikube, which is what I used here in this example. It runs it in a VM on your laptop. It's really easy to use. If you want to try it with more servers, I highly recommend using Google Cloud for that. Azure and AWS also have Kubernetes offerings, but you can sign up for Google Cloud, get $300 free for a year, and you can run like a big cluster to play around with, and it's going to be pennies. And spin it up, play with it, shut it down when you're not using it, and that $300 will last you a long time. But you can definitely recommend that.
If you want to make your $300 last longer, use preemptible nodes. 30% discount.
Yes, he knows because he works for Google. So if there's no other questions, before we go, I just need to tell everybody that lunch is in Pristina, which is where all the sponsors are set up. I work for Navuli. We're there. We're next to Google. Come by, see us, see a demo of our products, get a free T-shirt, get some lunch. And if you have any questions, I'll be here all weekend. Feel free to stop by. Thanks.